Good morning children. Today we will discuss about the aromatic hydrocarbons. Aromatic hydrocarbons means those are hydrocarbons which are containing either a benzene ring or it may be a non-benzene compound, but it has a cyclic structure. So that will be called as a aromatic hydrocarbon. Okay. So the most common aromatic hydrocarbon which we are going to study is benzene. Okay. Benzene, and whichever compound has this benzene ring, either one benzene ring or two benzene ring which are fused together or three benzene ring which are fused together, they are all coming under the compounds which we call as aromatic hydrocarbon. Okay. So this is your benzene. ठीक है. If you have two fused benzene rings, then this is your naphthalene. This is again aromatic hydrocarbon. Okay. So these are examples. Various other examples are also given in your textbooks of aromatic hydrocarbons. Okay. So these aromatic hydrocarbons, this is anthracene. Followed everyone? Okay. So these kind of compounds, they will be called as aromatic hydrocarbons. If it is containing a benzene ring, then it will be known as benzenoids. If it is not containing a benzene ring, then it will be known as non-benzenoid aromatic हाइड्रोकार्बन्स. ओके. नॉन बेंजीनॉइड एरोमेटिक हाइड्रोकार्बन्स, जैसे ये वाला देख लो. ओके. थायोफीन, इट इज़ अ नॉन बेंजीन एरोमेटिक हाइड्रोकार्बन. नॉमेनक्लेचर ऑफ हाइड्रोकार्बन्स, aromatic hydrocarbons, we had discussed in the previous chapter. Okay. Like the name of this structure which is having the formula C6H6, it is called as benzene. ठीक है. Then if there are substituents present on the benzene ring, say for example CH3 is the substituent, then this will be methyl benzene. ठीक है. So that naming and all we had done in the previous chapter. So we will not go again into the naming. One or two we will just observe. Say for example, if CH3 is it is disubstituted compound, disubstituted benzene. This will be known as 1,4-dimethyl benzene. Clear? Okay. Even we can observe isomerism in these hydrocarbons. Isomerism what means? What? Same structure, same molecular formula but different structural formula. जैसे ये तुम्हारा मिथाइल बेंजीन है. If it is disubstituted, then I will get 1,2-dimethyl benzene. Okay, the name of this compound is 1,2-dimethyl benzene. Okay. If this CH3 is substituted some other place, not at the second position but at the fourth position, the name of this compound will be 1,4-dimethyl benzene. So both the methyl groups, they are at different positions in these two compounds. If you just observe the molecular formula, it will be the same. Okay. So therefore this kind of change in position of the substituents gives rise to isomerism. So this is the isomerism which you observe in aromatic hydrocarbons. Okay. Position of these substituents will change but the molecular formula will remain same. That kind of structures would be called as isomers. Okay. So in aromatic hydrocarbon also you can observe isomerism. Followed. Now the next topic is how could we decide upon the structure of the benzene. Okay. So we will go into that now. First You can note this down. Now let us discuss about the structure of benzene. Okay, structure of benzene. ठीक है, the molecular formula. Okay, molecular formula of benzene was found to be C6H6. Now if it was an alkane with carbon 6, alkane with carbon 6 मतलब C6H2 into 6 plus 2 which is equal to C6, 6 2 12, 13, 14 ऐसा होना चाहिए था, लेकिन उसके पास कितना का हाइड्रोजन कम है, 8 हाइड्रोजन्स कम है, indicating that benzene, which implied या indicated that benzene is highly unsaturated compound. It is highly unsaturated compound. तो ये है बेंजीन वॉज हाईली अनसैचुरेटेड कंपाउंड, मतलब उसमें बहुत सारी डबल बॉन्ड्स हो सकते हैं. ओके, विच लेड टू द थिंकिंग दैट बेंजीन कुड हैव दिस पर्टिकुलर स्ट्रक्चर, एंड दिस वॉज गिवन बाय अ साइंटिस्ट नेम्ड केकुले. ओके, दिस इज द केकुले स्ट्रक्चर ऑफ बेंजीन. बेंजीन, ठीक है, केकुले ने ये स्ट्रक्चर प्रपोज किया वेयर ईच कार्बन इज sp2 हाइब्रिडाइज्ड. ओके, ईच कार्बन विच इज प्रेजेंट इन दिस 6 हेक्सागोनल स्ट्रक्चर, 6 कार्बन containing hexagon, each one of them is sp2 hybridized. Okay, also since there are three double bonds which are present, how is this 3 double bonds formed? Let us just understand that first कि कैसे ये structure है. See, each carbon is undergoing sp3 hybridization. So sp2 hybridization. Okay, so here this carbon also will undergo sp2 hybridization, isn't it? It will undergo sp2 hybridization and it will have 3 sp2 hybrid orbitals. Okay, so each carbon you can see it is undergoing sp2 hybridization to give you 3 sp2 hybrid orbitals. ठीक है, again here also you have a carbon, it also undergoes sp2 hybridization. Then you have a carbon here which also undergoes sp2 hybridization, giving rise to okay, you can draw the other carbon here so that it looks proper. Okay, this way. Okay, then here you have another carbon which is again undergoing sp2 hybridization. So this is how they had got the structure of this benzene. So each कार्बन sp2 हाइब्रिडाइजेशन हो रहा है और हर एक sp2 हाइब्रिड ऑर्बिटल्स ऑफ ईच कार्बन ओवरलैप्स विथ हाइड्रोजन गिविंग राइज टू द CH bonds. Okay, here you will find CH bonds present in this manner. That is how you get the structure C6H6. If you just observe, this is C6H6. Everywhere hydrogen is present. Okay, even though we don't write it, but there is hydrogen present with each carbon. So that is why the molecular formula C6H6. There is alternate double bonds present. Now each carbon would have an unhybridized p orbital, which you can show it this way. Okay, so each of them, each carbon will have this unhybridized p orbital. So this unhybridized p orbital is the one which is forming a pi bond. Okay, similarly यही, अब जरूरी नहीं है इन दोनों के बीच ही pi bond बने. Okay, This will also have similar way. You have unhybridized p orbital, the one which participates in the pi bond formation. Okay? Same way here also there will be a pi bond formation taking place. You can see this is a pi bond formation. So that is how this double bond comes, this double bond here. Okay. Now it was observed कि ये स्ट्रक्चर ज़रूरी नहीं है पाई बॉन्ड इन दोनों के बीच ही बने. इट कैन बी ऑल्सो फॉर्म्ड बिटवीन दीज टू कार्बन एटम्स. ऑल्सो इट कैन बी फॉर्म्ड बिटवीन, इंस्टेड ऑफ दीज टू कार्बन एटम्स इट कैन बी फॉर्म्ड बिटवीन दिस टू पेयर्स. मतलब ये दोनों पेयर के बीच में भी हो सकता है. ठीक है. वैसे ही ये दोनों के बीच भी बन सकता है. ओके, बिटवीन दीज टू. So this, there is actually a cloud. Again it is possible that these two can be forming the pi bonds. Followed. So you can find that there is a pi cloud above and a pi cloud below. So in your text this, it's difficult to draw on the board, but in the textbook it is given. There will be a pi cloud above the CH bonds and also it will be below. So that is led to the conclusion that these electrons, these electrons which are in the form of double bond, they are not localized, they are continuously moving or they are delocalized. अभी यहाँ पे है तो then it will be going into this manner. Okay, so that is how we can understand the structure of benzene. There will be 6 carbon in this benzene and 6 hydrogens, and there is an alternate double bond between the 2 carbon atoms, and these double bonds, the electrons are delocalized, that is they are moving, they are in motion. Okay, and that is that we can understand with the help of resonance. Resonance is what? Movement of electrons from the region of higher electron density to the region of lower electron density. Okay. So it was observed that this is how you have a pi cloud above and a pi cloud below. The pi cloud, when I say, it means pi electron cloud. Okay. Pi electron cloud above the CH, it is a planar molecule. Above the CH bonds and below the CH bond there will be electron cloud which keeps on, it is delocalized, the electrons are not fixed there. So that is how structure of this benzene can be understood. Now everyone will observe that there are 3 double bonds in this structure. So naturally benzene should undergo the reactions of unsaturated compounds, like say addition reactions. Addition reactions, the unsaturated hydrocarbons easily undergo addition reactions, but you will find that benzene, benzene, it does not undergo addition reaction under normal condition. But if you take very high temperature, say greater than 500 Kelvin or around 450 to 500 Kelvin, then it may undergo the addition reaction, giving you the corresponding cycloalkane. That is 3 hydrogens are added at these three double bonds. Okay. So you get the corresponding cyclohexane. So this is one reason which led to the thinking that there will be high unsaturation in the benzene ring. Okay. Also addition reaction with chlorine in presence of either sunlight, okay, H nu, sunlight, the addition reaction will take place to give you 3Cl2, benzene hexachloride बनता है, benzene hexachloride is formed. Okay, this is known as benzene hexachloride. So this is again an addition reaction, but it takes place under, normally it won't react, but under a certain specific condition it will undergo the addition reaction. Even benzene undergoes the reaction with ozone, 3 molecules of ozone to give you benzene triozonide. Okay, benzene triozonoid. So this is also supporting the fact that there are 3 double bonds present in the benzene ring. Okay. Now Kekulé said that the 3 double bonded with the 3 double bonds benzene structure is of this kind. Now it is possible that later on when resonance was explained, then we could have understood, then we could understand that these pi electrons, they are not localized, that is the double bonds are not fixed but it keeps on rotating. Earlier केकुले का ऑब्जेक्शन, केकुले का स्ट्रक्चर ये था, बट उसका स्ट्रक्चर को देर वर ऑब्जेक्शंस. वन ऑफ द ऑब्जेक्शन वाज दैट द अनसैचुरेटेड कंपाउंड्स जैसे एडिशन रिएक्शंस को फॉलो करते हैं वैसे बेंजीन डज नॉट फॉलो अंडर नॉर्मल कंडीशन. दैट वाज वन रीज़न वाई केकुले का स्ट्रक्चर वाज नॉट कंसिडर्ड टू बी प्रॉपर फॉर द बेंजीन. ठीक है. सेकेंड ऑब्जेक्शन वाज दैट कि बेंजीन undergoes substitution reactions which is common with alkanes. Okay, benzene undergoes substitution reactions very easily instead of addition reactions. So that also was an objection to the Kekulé structure. Then another objection was that if only one kind of if the bonds are not rotating, yeah, it is not localized, then ये जो डाइब्रोमो कंपाउंड है ना ब्रोमीन का, उसका 2 आइसोमर बनना चाहिए, एक ऐसा, और इफ द ब्रोमीन इज सब्सटीट्यूटेड एट दिस पोजीशन देन you could have bromine with the single bond. Bromine is present with the carbon having single bond between them, or here the bromine is present with the carbon having double bond. मतलब 2 तरह का आइसोमर बनना चाहिए. लेकिन एक्सपेरिमेंटल वाइज इट वाज फाउंड दैट ओनली one dibromobenzene was being formed. So this is the ortho substituted dibromobenzene. यहाँ पे bromines are present between the carbons having a double bond. Here the bromine is present between the carbon having the single bond. तो मतलब 2 तरह का बनना चाहिए isomers for dibromobenzene, but it was found only one type of isomer was being formed. So that led to the conclusion, या केकुले ने उसको कैसे rectify किया, उन्होंने कहा कि this double bonds are continuously in motion, that is it goes on changing from one position to another. That is how it led to the conclusion that benzene, it has a resonance hybrid of these 2 structures which is found to be we represent it as a circle. Okay. Also one more objection was there, अगर हर एक कार्बन और between the 2 carbon atoms, if there were single bonds and if there were double bonds, then naturally the bond length should be coming out as, अगर सिंगल बॉन्ड है तो 154 पिकोमीटर आना चाहिए, और अगर डबल बॉन्ड है तो 133 पिकोमीटर आना चाहिए, 134 पिकोमीटर आना चाहिए. डबल बॉन्ड, if it is present between the carbon atoms, then the bond length should be 134 picometer, and if the single bond is present between the 2 carbon atoms, then the bond length should be 154 picometer. But when experimentally it was found out by X-ray diffraction and all, it was found out that the bond length which is present between the carbon and carbon atom in the benzene ring, it was found to be 139 picometer, which was an intermediate value between these 2 values. Okay, 139 picometer आता है, तो neither it is a double bond nor it is a single bond, it is having an intermediate value. That also led to the conclusion that benzene is not having a fixed या resonance structure 1 या resonance structure 2 नहीं है उसका actual structure. Actually it is a resonance hybrid of these 2 structures. Okay. So resonance hybrid मतलब the electrons are keeping on moving inside the ring. Okay. The pi cloud of electron, it is delocalized, it is not fixed. So that is how the structure of benzene can be understood. So how was the structure? The structure was, it is a cyclic structure which has 3 carbon atoms bonded with each other, having an alternate double and alternate single bonds. Okay. So, that is how the structure of benzene was found out. Okay. For any compound to be aromatic in nature, there are certain set of rules which it should follow. So, conditions for aromaticity, it is that first condition is that the molecule should be planar. Okay, the molecule should be planar. Okay, that means the molecule should, all the atoms of the molecule should lie in the same plane. Okay. Second is there should be complete delocalization of the pi electrons. There should be complete delocalization. There should be complete delocalization of pi electron. And thirdly, it should follow the Huckel's rule. Okay, it should follow the Huckel's rule, which is 4n plus 2 pi electrons. 4n plus 2 pi electrons should be present. 4n plus 2 pi electrons should be present. If these three are followed, then you can say that the compound is aromatic in nature. So, ek do molecule leke let us try to understand. Okay. So, first one, let it be benzene. Okay, benzene. Is it a planar structure? How can we come to know that each of these carbon, no, it is sp2 hybridized, and sp2 hybridized carbons always they are located in the planar, it will be in the same plane. Okay, all the carbon hydrogens will be in the same plane. So, it is a planar structure. There is complete delocalization of pi electron, that is there is resonance occurring here. Okay, pi electron matlab kya hai? Electron which forms the pi bond. Okay. Now, is it following Huckel's rule? Now, here 4n plus 2 pi electrons hona chahiye bol rahe, where n can be 0, 1, 2, it can go on. So, isme how many pi electrons do you see? 1, 2, 3, 4, 5, 6 hai. So, if you take n equal to 1, therefore, it will follow 4 into 1 plus 2, which is equal to 6 pi electron. It is having 6 pi electron, isn't it? Now, look here. Here also there is double bond present between these carbon atoms, and you can see that here the n value, if you put, what is the n value, what is the number of pi electrons you can observe here? You can observe that there are 1, 2, 3, 4, 5, 6 pi electrons are there, that is delocalized electron. Okay. So, again this electron can shift here, then it can keep on rotating. So, this cycloheptadienyl anion, it is also planar in nature. Okay. And also there is delocalization of the pi electron, and you will find that there are how many pi electrons present? There will be 6 pi electrons present. Okay. Similarly, here also you can find 6 pi electrons are present, and it is also planar in nature. There is conjugation. Always remember, whenever there is conjugation, that will be planar molecule. Here conjugation have एक single bond, next pi bond, single bond, pi bond, single bond, it should go on. ठीक है. Similarly, you can also observe this naphthalene, anthracene. Here N, if you take, there are how many pi electrons you can observe here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pi electrons are there. So, if you take n is equal to 2, then this rule is followed, no? 4 into 2 plus 2, which is giving you 10 pi electron, and 10 pi electron are present here. So, this is also a aromatic compound. It is planar in nature, and also it will be having complete delocalization of the pi electron. Similarly, anthracene, here if you take n is equal to 3, then it will follow the 4n plus 2 rule. That is 4 into 3, that will be equal to 12, 12 plus 2, it will be 14. Do you find 14 pi electrons? Just to check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 pi electrons are present in anthracene. So, this is how you can find out whether a compound is aromatic or not. ठीक है, अब तुम ये वाला मॉलिक्यूल लेके देखो, is this aromatic in nature? It will be aromatic in nature because all the all the pi bonds, they will be delocalized. Also they are planar in nature, and it will follow the Huckel's rule. Okay? So, that is how you can understand aromatic nature. Now, let me take this compound. Is this aromatic in nature? This is cyclopentenyl, cyclopentadiene है ये. Okay. So, is this aromatic in nature? See, here this carbon is having a sp2 hybridization. Also, this carbon is having sp2 hybridization. But when you come to this carbon is sp3 hybridized. So, then this is not an aromatic, क्योंकि sp3 hybridized में क्या हो जाता है, all the carbon, the hydrogens won't be lying on the same plane, it may be above the plane also. So, it is not a planar structure. Also, does it follow Huckel's rule? That also you should see. For any value of n, will it have coming out as 4 electrons? No, no, because 4 अगर n 0 भी ले लेते हैं तो कितना आता है, 4 into 0, 0 plus 2 आता है. Okay. So, it is not having 2 pi electrons, it is having 4 pi electrons. So, it is not following the Huckel's rules, it is not planar in structure, therefore, this is not any one of the condition is not followed, then also it will be not planar or not aromatic in nature. Okay. So, this is how we can understand how aromatic hydrocarbons to be identified. Okay. Next time we will take the preparations of benzene. Okay. Thank you.